Hello everyone, welcome back. So in this video we are going to learn about the basics of RH criterion. Okay, so RH criterion. So if you are first time to my channel, please consider subscribing. So if you subscribe and encourage me, I can do more videos like this. Okay, so RH criterion is, its full form is Routh Hurwitz criterion. Okay, so given by two scientists, Routh and Hurwitz. Okay, so why this Routh Hurwitz criterion is used, or what is the main purpose for this? RH criterion is mainly, so this is very important point, it is mainly used to find the number of poles in right half of S-plane. Right half of S-plane. Okay, so this is mainly used. So RH criterion is mainly used to find the number of poles in the right half of S-plane. So when you find the number of poles in the right half of S-plane, then we can comment on stability. Yes or no? So when you find the number of poles in the right half of S-plane, if there are no poles in the right half of S-plane, then we can find the stability of the system also. So this RH criterion is used to find closed loop system stability also. Closed loop system stability also. Okay, so again it comes from the first point only. So RH criterion is used to find the number of poles in the right half of S-plane and number of poles in left half and imaginary axis. Imaginary axis can also be found by using RH criterion. Okay, so by using RH criterion we can find the number of poles in left half and right half of the left half, right half, and on the imaginary axis. So next, RH criterion, if the system is conditionally stable system, for a conditionally stable system we can find the range of K value. We can find the range of K value, the system gain. Okay, so we can find the range of K value for which the system is stable. Okay, so for a conditionally stable system we can find the gain value K for which the system is going to be stable. That is, we are going to find the range of K. Okay, so we are going to find the range of K is found. Okay, so if the system is marginally stable, in that case also we can find the system gain K. Okay, so finding the K value, that is finding the system gain value when the system is marginally stable, also is possible by using RH criterion. Okay, so we'll see all the cases when we discuss one by one. Okay, and if the system is marginally stable, we can also find the omega n value. Okay, since we have constant amplitude and frequency of oscillations, so we can find the sustained oscillation frequency. Also we can find from RH criterion. Okay, and lastly we can also find relative stability. Also by using RH criterion, that is gain margin and phase margin concepts. Okay, all these we'll discuss later. Okay, so don't worry about this. So these are the main things which we are going to use, which we are going to find by using RH criterion. So the main important point is this: RH criterion is mainly used to find the number of poles in the right half of S-plane. Okay, so another important point which is asked many times is the difference between the RH criterion, difference between RH criterion and other stability techniques. Okay, so what is the difference between RH criterion and other stability, right? Like root locus, Bode plot, Nyquist plot. Okay, so all these also are stability techniques only. Okay, but Bode and Nyquist are frequency domain stability techniques. Root locus and RH criterion are time domain stability techniques. Okay, this is the first difference between RH criterion and remaining techniques. So RH criterion and root locus are time domain stability techniques. Bode plot and Nyquist plot are frequency domain stability techniques. Okay, so they are also used to find the stability of the closed loop control system only, but they are used in frequency domain. Okay, so the main difference between RH criterion and remaining all this, including a root locus, is RH criterion uses closed loop transfer function to find closed loop system stability. Closed loop transfer function to find closed loop system stability. Okay, so RH criterion uses closed loop transfer function to find the closed loop system stability, but all other remaining techniques like root locus, Bode plot, Nyquist plot, all these uses open loop transfer function to find the closed loop system stability. So all the remaining techniques uses open loop transfer function to find the closed loop system stability, but only RH criterion uses closed loop transfer function to find the closed loop system stability. Okay, so this is the basic difference or main difference between RH criterion and other stability techniques. Okay.